We present a novel approach to tactile object classification via rolling. Our robot hand is designed to extend the rolling range of objects during rolling tasks, using 2 fingers with the rotary joints and a prismatic palm. The prismatic palm dynamically adjusts the palm width to keep the 2 fingers parallel to each other, more than doubling the angular displacement of a 100 mm diameter cylinder. A barometric tactile sensor array is mounted on 1 finger to collect tactile data from 3 objects via a predefined rolling procedure. This heat map shows the spatiotemporal data collected during rolling a hexagonal prism. We observed that the lateral edges and faces of a prism create differently shaped peaks and designed numerous features to describe those peaks, namely peak duration, amplitude and time to peak, as well as calculated skewness. We finally trained a subspace KNN model on those peak features extracted from rolling each object 30 times, resulting in a validation accuracy of 95.6%. Thank you for your attention.